So here in this part we are going to do C amplifier frequency response. Okay, C amplifier frequency response. The graph is empty, the table is empty. So here what we are going to do is set the values across the components by adjusting the slider here. So after adjusting all the values across the sliders, that is the components here, click on add to table and vary the frequency and click on add to table. During that process we'll fill a table here, and after that click on plot to create a graph here. Okay, so let us start the part. So initially we will set the frequency, that is minimum is 50 Hz and the source resistance is minimum is 100 ohms, and the collector coupling capacitor is 10 microfarads, and RB1 and RB2. RB1 is 33 kilo ohms, and RB2 is 8.2 kilo ohms. And coming to coupling collector resistor RC here, so the collector resistance 2.2 kilo ohms, and the emitter resistance is 1 kilo ohm. Coming to the output coupling capacitor CC2, it is 1 microfarad. So just slide this one and move it back to create 1 microfarad. And the bypass capacitance is 10 microfarads. Load resistance, so we have to adjust it initially. Minimum is 100 ohms and maximum is 4000 ohms. It is 4 kilo ohms. So leave it as 4 kilo ohms. We cannot leave it as no load. Okay. So with a 50 Hz frequency, we can create a value here, add to table. That is, we got 9.8 dB. So like that, vary frequency and click on add to table. We may vary in step size of 100 or 1000 like that. We may see a maximum value. So 36.4, I think it is nearly maximum value here. Yes. So vary the frequency in terms of multiples of tens or hundreds or thousand to plot graph perfectly. So I am stopping here. Why? Because 36 is maximum gain in dB. 36 minus 3 is 33. So we have crossed that value also. Now click on plot. So it creates a graph here. It creates a graph here like this. So the maximum gain we obtained here is 36.4 dB. So somewhere here cutoff frequency will be there, nearly 33 value. Similarly on the other side also, somewhere here between these two will have some 33 value. So as part of this experiment C amplifier in the syllabus, here we are required to calculate the no load and loaded gain. So loaded gain we have calculated, that is we got 36.4 dB, that is gain in dB. But no load gain is not possible. Why? Because the load resistance maximum is here 4 kilo ohms only. We cannot make it no load, that is open. Okay, and other two parts what we have to calculate here is the input and output resistance. So to calculate the input resistance, we must vary this resistance such that output voltage becomes half of the maximum value we have obtained here. So to do that process, this table or experiment does not support properly. Why? Because we must vary frequency and click on plot. otherwise we can't move with we can't generate values. Okay, but what is supposed to do, we are supposed to do here is fix the input voltage and frequency. Now, don't vary this, but vary RS only, so that the output must be half of the maximum value. In this way we have to calculate input resistance. Similarly, to calculate output resistance, here I told you without load we have to obtain the V0. Okay, and with load we have to by varying RL we have to obtain every time V0 such that so that final value of whatever may be the value of this RL at that point the output must be half of the no load voltage. Okay, no load voltage, so that we'll get if initial no load voltage is V0 dash, we may get here a value for so for some RL V0 dash by 2. Okay, so that becomes the output resistance of this circuit. Output resistance of this circuit. So these things are not possible here by because every time the frequency must be changed. Okay, the frequency must be changed to generate a plot value here. Otherwise, the table won't accept what you call the process. So we'll do in multisim that process. But this is how we do virtual lab experiment for C amplifier to obtain the loaded gain. Load means here some RL is connected as 4K. Thank you.